everyone. Today I am going to teach you about the sum of the infinite GP. This is very interesting and fantastic topic in which the terms infinite, that means it will not will stop at a point, it will go infinitely in the infinite GP. So how this is working and how we calculate the sum of infinite GP and what is the GP. So GP means geometric progression. As you have studied about the AP, that means arithmetic progression in class 10th, but in class 11th you will study about the geometric progression. So I am going to teach you about the sum of the nth term of the GP, of the infinite GP. So first of all, what is the meaning of GP? GP means geometric progression. So how we'll understand the GP? Let's suppose a term 2 and let's suppose a term another 4 and 8, 16, 32 and let's continue this. So in this you are able to see that first term is the 2 here. So write the first term as A as we have the 2 here, and the second terms, this is the sequence in which a number is going on and going on to the infinitely. This is the symbol to write the infinite or so the infinite. So as we know that if we multiply in this 2, then we get the 4, and if we multiply the 4 into the 2, then we get the 8, and if we multiply the 2 in this, then we get the 16, and if we multiply, then we get the, and if we multiply 2 another, then we get the 64. So it will continue. So if you are multiply a common number, then you are able to get these sequences, which called the GP. So let's suppose the another GP, just like the 2, 3, 4, 5, 6. So this is the not GP, because when you multiply something, then you will not get the other number. So in this term, you are able to see that this is the sequence in which if I multiply a common number, the common number which you multiply is named as the R. Name is the common ratio. The name is the common ratio, and the first term of the GP is written as the 2. So as you are able to see that, let's suppose the another GP. This one is the 3, and if we write here the 6 and then the 12 and the 24, then it will go infinitely, then it is called the GP, because you are able to see that here we multiply the 2 and again we multiply the 2 and again 2, and if we write here the 3, and if you able to multiply a common number which name is the R, here as you have written the common ratio, if you multiply a common number and you are able to get the value to infinitely many values, then we call those sequences as the GP. So I think you understand what is the meaning of the GP, and today I am going to talk about getting the sum of the GP, sum of the infinite GP. That means, let's suppose as you are able to get this, that this sequences is the GP. As you are able to get this sequences is the GP. So if it will go infinitely, not will prevent or stop at any point, and it will go infinitely means continue. So if I will add those number, so what will be the number which we will get when you add those infinitely GP, when it will not continue? So it seems to be impossible to add because it will continue. So how we could add? If it will prevent or stop at a point, then we could add. Let's suppose it will prevent at this one point, then we will able to add those number all. If it not prevent, then how will we add? This is the concern we arises here. But I am going to add today's those number. So not exactly I could add this one, because this is the GP where the R is the 2, and you could add the GP if the R is less than, greater than -1 but less than 1. So if the ratio, as you able to see there, the ratio, the common ratio is the 2 in this GP. If let's suppose the GP, let's suppose the another GP in which if the R is lying between the -1 and the 1, then you could calculate the sum of the terms of the GP. Let's suppose the another GP 2, 1, 1 by 4 and 1 by 8. So in this you are able to see that it is by 2 as it is the common ratio, then you able to get 1 by 4. And if you multiply the 1 by into 1 by 2 into 1 by 4, you are able to get the 1 by 8. That means it is the GP. And where? So that you are able to get that it is the GP because you are multiplying a common number and you are getting it. So it is the infinite GP where the R we get, which is the 1 by 2. So as we know that the condition we need to calculate the sum of the infinite GP is the R should be lie between the -1 and the 1. So as we able to get that 1 by 2, that means 0.5, which lies between the -1 and the 1. So this is how we could calculate the sum of the terms of this GP. That means if I will write here the plus 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 and it will continue, then we will able to calculate what will be the sum of all the terms if it will go indefinitely. Again you are able to confuse that if we continue to go, so how we able to calculate. So for this I am going to teach you another concept or to make this understandable, that is something like this. Wait for a while. So let's suppose I have written here the 2 and if we multiply this 2 by the 2, then we will get here the 1. And if we multiply this 2 again, this 2 by the 4, then we will get the 1 by 2. If we multiply this 2 by the 5, then we will get something a smaller number. And if we multiply by the 2 by the 8, then we will get the 1 by 4. And if we multiply this 2 by the 100, then we will get 1 by 50. So as you are able to get that or able to understand that by this thing, if we increase the value of the denominator, then we used to get here the smaller value. So if I will multiply, if I will take here the infinity, that means it is a very large number. Just mean like this, it is a very large number. If I will divide by a very large number to the 1, then 2, then we will something get equal to the 0, not equal to the 0, but it reaches toward the 0. If we multiplying by a highest number in the denominator to a smaller number, then we are getting toward the 0, tends to 0. So that we multiply the, let's say 2 by the infinity, then we tends to the 0. That means infinity here a very large number, just like this you could imagine, a very large number. So as you are able to get that when we increase the denominator, then we able to get the smaller value. When you multiply the by the 2, then we get the 1. When you multiply by the 4, that means you increases the denominator, then you get the 0.5. So 0.5 the smaller, and when you multiply something a larger number than 4, then you again able to get this number which is the 0.25. So again if you are increasing the denominator, the value of the denominator, then you are able to get a smaller number. And if this value is increases to the infinity, then you will get sometime a 0. So this means you would calculate the sum of the infinite GP. So let's suppose a GP. Again I am going to take another GP, which is the 2 plus 1 by 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, and it will continue to the infinite. So it will prevent a one day. It will stop not one day because it is continue to go. And in this, what is the common ratio? The common ratio, that means if you multiply a common number next to it, then you are able to get it. So for this you have how to calculate the common ratio. For any GP or any GP, you have to calculate the common ratio. Then take any two consecutive number, just like this one. If you will take and multiply by the first this one 1 by 4 by the divide the 1 by 4 by 1 by 2, then you will able to get 1 by 2. And you could take the any two consecutive number, just like you could take this one two consecutive number and divide the 1 by the 2, so you will able write first the 1 by 8 and again 1 by 4, then you will able to get the 1 by 2. So you could take any two consecutive number and you will able to get the common ratio. So in this GP we have the common ratio R is equal to 1 by 2. 1 by 2. If I have to calculate if it will continue this term, adding this term, so what will be the final answer, or what will be the sum of this GP? So for this we have a formula. Sum of the infinite GP is equal to a plus 1 minus R. So what is the A? A means first term of GP. So what is the first term of this GP? The first term is the 2. So write here the 2 and 1, and what is the R here? R we have the 1 by 2, and here we have the sum of infinite GP is equal to, if we solve this one, so we get the LCM as the 2, and 2 minus 1 is equal to 1 by 2, and again here be 2. So here we get the value as a 2 by 1 by 2. So if we solve this one, we get the 4. So sum of the infinite GP, we get the 4. That means here you are able to get that 2 plus 1 3, and if we calculate this one, that will go to the infinite. That means sum of this from here to all those infinity will be the only one, because the sum of 2 plus 1 becomes the already 3, and sum of all those terms of the GP become the 4. So we have one remains the 1, and 1 if we calculate this one to the infinitely, then we will get the 1. So I think you understand the concept of GP and how interesting this is, and thank you for today.